Hi students, I'm Praveen Sebastian Paul. In this lecture we are discussing about the object-oriented model. The object model visualizes the elements in a software application in terms of objects. In this lecture, we will look onto the basic concepts and terminologies of object-oriented systems. First of all, we are going to discuss the object and classes. The concept of object and classes are intrinsically linked with each other and form the foundation of object-oriented paradigm. When it comes to the term object, an object is a real-world element in an object-oriented environment that may have a physical or conceptual existence. Each object has the following. First of all, identity that distinguish it from other objects in the system. Secondly, state that determines the characteristic property of an object as well as the value of the properties that object holds. And thirdly, behavior that represents externally visible activities performed by an object in terms of changes in its state. Objects can be modeled accordingly to the need of the application. An object may have physical existence like a customer, a car, etc., or an intangible conceptual existence like a project, a process, etc. So simply, an object is a real-world element in an object-oriented environment that may have a physical or a conceptual existence. The second term is a class. A class represents a collection of objects having same characteristic properties that exhibits common behavior. It gives the blueprint or description of the object that can be created from it. Creation of an object as a member of a class is called instantiation. Thus, object is an instance of a class. The constituents of a class are a set of attributes for the objects that are to be instantiated from the class. Generally, different objects of a class have some difference in the values of the attributes. Attributes are often referred as class data. Secondly, a set of operations that portray the behavior of the objects of the class. Operations are also referred as functions or methods. So these are the basic two constituents or properties of a class. For example, let us consider a simple class circle that represents the geometrical figure circle in a two-dimensional space. The attribute of this class can be identified as follows. So it has x coordinate to denote the x coordinate of the center. Secondly, it has y-coord to denote the y-coordinate of the center, and a to denote the radius of the circle. Some of its operations can be defined as follows, that is, find area of, which is a method to calculate the area, and secondly, it has find circumference of method to calculate the circumference of that particular circle, and thirdly, it has scale of method to increase or decrease the radius of that particular circle. So this is an example for this. And another term is an encapsulation. Encapsulation is the process of binding both attributes and methods together within a class. Through encapsulation, the internal details of a class can be hidden from outside. It permits the element of the class to be accessed from outside only through the interface provided by the class. So encapsulation is the process of binding both attributes and methods together within a class. Another term is data hiding. Typically, a class is designed such that its data can be accessed only by its class methods and insulated from direct outside access. This process of insulating an object's data is called data hiding or information hiding. For example, in the class circle, data hiding can be incorporated by making attributes invisible from outside the class and adding two more methods to the class for accessing the class data, namely set value, which is a method to assign the values of x coordinate and y coordinate, and a get value method to retrieve values of y coordinate and x coordinate. And here the private data of the object cannot be accessed directly by any methods that is not encapsulated within the class circle. And the term is message passing. Any application requires a number of objects interacting in a harmonious manner. Objects in a system may communicate with each other using message passing. Suppose a system has two objects, object 1 and object 2. The object 1 sends a message to object 2 if object 1 wants object 2 to execute one of its methods. The features of message passing are: firstly, the message passing between two objects is generally unidirectional. Secondly, message passing enables all interactions between the objects. Thirdly, the message passing essentially involves invoking class methods. And fourthly, objects in different processes can be involved in message passing. Now we are going to discuss the term inheritance. Inheritance is a mechanism that permits new classes to be created out of existing class by extending and refining its capability. The existing classes are called the base class or parent class or superclass, and the new classes are called the derived class or child classes or subclasses. The subclass can inherit or derive the attributes and methods of the superclass, provided that superclass allows so. Besides, the subclass may add its own attributes and methods and may modify any of the superclass methods. Inheritance defines an is-a relationship. For example, from the class mammals, a number of classes can be derived, such as human, cat, dog, cow, etc. Human, cat, dog, and cow all have the distinct characteristics of mammal. In addition, each has its own particular characteristics. So it can be said that cow is a mammal, and it can also be said that human is a mammal. So this inheritance defines is a relationship. So we can see different types of inheritance. Some of the common types are: first one is single inheritance, that is a subclass derived from a single superclass. Second one is multiple inheritance, that is a subclass derives from more than one superclasses. Third one is multi-level inheritance, that is a subclass derived from the superclass, which in turn is derived from another class, and so on. And fourth one is hierarchical inheritance, that is a class has a number of subclasses, each of which may have subsequent subclasses continuing for a number of levels, and so on, forms a tree structure. And another common one is the hybrid inheritance, that is a combination of multiple and multi-level inheritance so as to form a lattice structure. So these are the different types of inheritance. So my dear students, in this lecture we had discussed the common terms associated with object-oriented model. So we had discussed about object, classes, etc. So my dear students, kindly go through this assignment question. The assignment question is: define the following. First of all, object. Second one is class. Third one is encapsulation. Fourth one is data hiding. Fifth one is message passing. And sixth one is inheritance and the type of inheritance. So my dear students, in the upcoming lecture we will discuss another set of terms associated with object-oriented programming. Those terms includes polymorphism, generalization, specialization, link, association, degree of association, cardinality, aggregation or composition, and the benefit of object model. So my dear students, see you soon. Until then, goodbye, thank you, and all the best.